Before we go on to the next set of problems, let me point out something to you. If you have out your test references, find the page that we've been using for solubility rules and activity series. Get out your test references and find the page where you deal with solubility rules and the activity series of metals and activity series of halogens. Because there's something really cool on the other side of the page. How about that? Well, how about that? Yeah, well, we don't really care about Dolman High right now. We care about this stuff right here. All right, look at this. Look at here. What I got right here.
Wait a minute.
Oh, wait a minute.
Are you joking with me right now?
He's not joking.
You're not joking, are you?
No, it's right there on the test references. Now look, why did I not tell you up to now? Because I want you to know it well enough to know what to look for. Okay? I want you to be familiar with it before you start depending on the test references. You got it? But let's say you get stuck somewhere and you go look on the test references. There it is for you. Got it? All right. There's Charles' law above my thumb. That's the combined gas law right there. It's just got volume and pressure flipped around from the way we used it. There's Boyle's law. How about that? Got it? No, not really. Okay. The question was, does it matter whether volume or pressure comes first? Doesn't matter. Okay. And this is the one we're going to do next, the one that's above my thumb now. Tiny n, yes, it's a little n. All right. Let me stop. Captures. Okay. We combined Boyle's law and Charles' law to get what we call the combined gas law. If we combine Boyle's law and Charles' law with a couple of laws we don't even deal with in this class, one of them is Gay-Lussac's law, and one of them is, let's see, Avogadro's hypothesis, we actually can come up with this new law, which the fellow talked about in the video a while ago. The ideal gas law. All right? And the ideal gas law is really easy to remember because it's a reasonably fair description of Tyler. Pub nerd. No, I'm just kidding. Tyler's not a pub nerd.
What's a pub nerd?
That. Just a way to remember it. Pub nerd. Pub nerd.
I know, but what is a pub nerd?
Nothing. It's nothing. It's just a funny sounding nothing.
He just said I was nothing.
No, I also said it wasn't you. I was just kidding. Come on. All right. What?
You're a pub nerd.
He said, call me by my name, I call me nothing.
Call me by my name or call me nothing. Okay. Gotcha.
Call me pub nerd.
Well, listen, actually, if they call you a pub nerd, what are they calling you? Ideal. Oh. Okay. So, you know what some of these are already. Pressure, volume, temperature in what units? Kelvin units. I didn't hear. I heard maybe 3 people say it. Kelvin units. This N is the number of moles of a gas. Okay?
What does N stand for? The word,
It's a whole number. Like in math, N is a whole number, right? Not negative numbers.
So N is just there.
Yeah. Now, R doesn't vary. R is a constant. It's the ideal gas constant. Now there are different versions of R, but the value is the same. Okay? Different versions of R, but the value is the same. Here's what I mean by that. If you change the units of measurement, the numbers have to change, but the actual value of it is the same. It's like I said, 1 dozen, or 12. The values are the same, but I use different numbers, right? Okay? Or I say 1 mole, or I could say 6.02 times 10 to the 23rd, right? But they're the same thing. Okay. So again, going back to your test references, once I find my list, page 1, front page. 6 versions of R. 6 versions of R. R, universal gas constant it's called here. 6 versions. Very good question. Did y'all hear the question? Then y'all aren't listening. If you aren't listening, you don't know the question. If you don't know the question, you won't understand the answer. How do you know which R to use? Huh? The pressure units is what we're going to key on. These 2 versions right here I'm pointing to, those are used in doing calculations of energy, and we're not going to do calculations of energy with gases, so we're not going to worry about those 2. All these others, the only difference in the units of measurement that are attached to it are the pressure units. Okay? Atmospheres, millimeters of mercury, kilopascals, and torr. So all you have to do is match the pressure units with the other units of the problem. Now while we're here, to make a point, these are measurement units. They are not variables. You cannot plug values in the place of these units of measurement. A lot of students try to do that. That's not how you solve the problems. The variables are P, V, N, and T. You don't replace units of measurement with other numbers. Does that make sense? All right. So let's come up with a problem and see how this can be used. It would be helpful if y'all would stop talking and pay attention as I write this down. It would be a good idea if you were writing right now, yes. Okay. So with 25 liters of oxygen at 270.0 K, so I helped you out here. I didn't give it to you in degrees C this time. And 75.0 torr, that's a pressure unit. Or held in a balloon, how many moles of oxygen are there? Well, the first thing we do when we're solving a gas law problem is list your knowns and unknowns. Okay? So what known or unknown is this? Is that a known? That's a volume known. What? 270.0, yes. What known or unknown is this? How about this? Pressure. I just said it was a pressure. All right. Are there any, and that's all the knowns. Are there any unknowns? And what symbol do we use for the unknown? N. All right. That's the number of moles. We said earlier that's what it meant, number of moles. And so we've got V, T, P at N. And the only equation that you have that has all of that is PV equals nRT. But we haven't listed R. But you always have R. Always R. R is always there. It's always there with you, okay? You're never without R. We just have to figure out which one to use.
63 point something.
Okay? Good. We got to match this unit of pressure here with one of these here, and this is the one that matches the unit of pressure. So this R is 62.37 liters times torr over Kelvin times moles. Okay? Now, I need to turn a sheet of paper sideways to solve this. Yes, it's that long. So. Okay. We have pressure. We have volume. We don't have N. We have R. And we have T. All right. Once you plug in the things you know, the next step is, well, we're not quite ready to actually what I call solve, but it was kind of part of the problem solution process. But how do you solve? What do you got to do? Isolate the unknown. Here's our unknown. Pay attention. Okay? That's the unknown. We got to get it by itself. How can we get rid of this thing right here? Well, I suppose we could erase it, but why did we do it before? Multiply by the reciprocal. Okay? All right. We want to divide by this, but dividing this is the same thing as multiplying by its reciprocal. So let's do it that way. Okay? Oh, but this is so cool when we get to the end. Wait, just wait. Just wait. You should get excited right now. I wish everybody would get excited right now. We might keep Dylan awake. All right. What we did extra to this side, got to do to the other side. Okay? So let's go over to the other side and plug these two things, these two new fractions, over on the other side. And put both these over 1. Keep everything neat, nice and neat. So I'll put this fraction on the other side as well. So Kelvin times moles over 62.37 liters times torr. No, not Thor. Tor. Okay? And then I have to also put this fraction on the other side. So times 1 over 270.0 K. What? No, because this was originally here. This 270.0 K is this T. This is the thing we added. That's all we have to add on this side.
Yes, but you have to put the T on this side over there. You put the texture over there.
Yeah.
Yeah.
It's easier. Yeah, it's easier to tell how to cancel things when you put it over one. So I'm suggesting that you do that. Yes. I understand. Let's concentrate on this right now. This is the magic I want to deal with right now. Okay? All right. Pay attention. Look at this. How do we simplify this now? What do we cancel? This 62.37 liter store, I got one on the top and one on the bottom. The whole thing can cancel. Kelvin moles cancels. 270.0 K cancels. Everything's gone except N, which is what we wanted to do. We've isolated the unknown. Let's look at the other side of the equation. Can we simplify anything on this side? Sure. Tor can go away. Kelvin can go away. Liters can go away. And all we have left are moles, and that's what N is, moles, right? So now we have to do the math. And this math is the same math you've been using for a month. Multiply this times this, it equals. Divide by this, it equals. Divide by this, it equals. Okay? Same process. What? What? See this? I want to cancel all that. Hold on a minute. I'll put it up for you in a minute. All right. 75.0 times 25. Hit enter. Then we're going to divide by this. Enter. Then divide by this. And this is the answer we're looking for. Okay? All right. Looking through here, we only have units of moles left. We only have the N on the other side. We want to find the correct number of significant digits for our answer. Of the measured or calculated numbers, this one and this one only have 3 digits, so that's how many we want here. That's the least number of digits, 3. 0, the leading digit, is not significant, so we count 1, 2, 3, underline everything else. Draw an arrow to show that we're rounding off. And there's our answer. Got it? So, listen. Long problem here. Okay? Really long problem. I can't even fit it on the screen right here. Alright? It's really important that you keep everything neat and follow everything step by step. If you do that, the math at the end is easy. Okay? But you got to get all the other little pieces step by step carefully done. Got that? But it's nothing new because you've done all this stuff in algebra before. Yeah, I think so. I'll show you the homework in a second. Alright, so let's do a practice problem. Oh, I wasn't so nice this time. I didn't give you the temperature in Kelvin. Hint, hint. Hmm?
You're not finding in this finding
Alright, so here's a practice problem, and I've already given you the homework. So let's work on the practice problem now. See if you can get the answer.